Okay, now on to number 6. This is one where we're finding the domain of a rational expression. The expression is f of x equals 3 over x squared minus 2x minus 35. So the domain of a rational expression is everything except what would be not included because of the zeros of this denominator. So I need to factor this denominator, x and x for x squared, factors of negative 35 that add to this negative 2, which would be a negative 7 and a positive 5. Then if I set those both equal to 0, and solve them for x, that will tell me what will make the denominator 0, which is what needs to be excluded from the domain. So if I added 7 to both of these, I would get x equals 7, and here subtract 5, so x equals negative 5. So those are the numbers that we need to not include in our domain. So writing it in the interval notation, I would start at negative infinity, and then I would go to the first number here that I would come to on the number line, which is negative 5, in union with everything in between those two numbers is fine. So from negative 5 to 7, in union with, and then from 7 to infinity. Number 7. Determine the vertical asymptotes of the graph. So the function here is 1 over, then x plus 2, and x minus 4. So the vertical asymptotes are also coming from the zeros of the denominator, as long as they're not also zeros of the numerator, which I don't have to worry about in this example because there is no x in the numerator that would give me a 0 up there. So I'm just concerned with these two that are already nice and neat in factored form. So this one would be x equals negative 2, and this one would be x equals positive 4. And they are vertical asymptotes, which if you remember, those are those vertical lines that go through the graph that the graph doesn't come up, doesn't touch, it just comes up next to it. So that's actually these two answers because it's the equation of the line, which are both x equals. And if you look at your paper, it is a multiple choice question, so you're looking for x equals negative 2 and x equals 4, which would be the A choice. Number 8. Another determining the vertical asymptotes problem. So this one, the function is f of x equals x cubed over 4x cubed minus x squared minus 18x. So again, I need to find the zeros of the denominator. In this case, there will be 3 since it's x cubed. The first thing I notice that I can do is pull out an x, since they all have one, take out an x, and then put in parentheses what is left, which would be 4x squared minus x minus 18. Now, since I've got it down to x squared, I can take that and put it in my quad program on my calculator, which would be that put the A is 4, the B is negative 1, and the C is negative 18. Put that in your quad program to get the other two zeros. So this creates a 0, x equals 0. The other two come from your quad program. So when you punch those in, hang on, I gotta punch it in. You would get 9/4 and negative 2 as the other two zeros. But remember, it's only a vertical asymptote if it's a 0 of the denominator but not a 0 of the numerator. So if you look at the numerator, if you plug in a 0 for this x and cube it, you're going to have 0. So the 0 of the numerator is also 0, which kind of think that one cancels that one. If it's a 0 in both spots, then it's not a vertical asymptote. So the only two vertical asymptotes would be the x equals 9/4 and x equals -2. All right, number 9 is a graphing problem. Let's start over here. We're going to find the domain, any asymptotes, and the x and the y-intercepts of the graph. So my function, f of x equals 3x plus 1 over x. The first thing it wants me to do is to find the domain. So the domain comes from the zeros of the denominator need to be excluded. So the 0 of this denominator would be 0. So everything except 0 is what is included in the domain. So -infinity to 0 in union with 0 to infinity, which would be the B choice on the multiple choice. Now, the x-intercept, which is the next thing that we're finding, is the 0 of the numerator. What makes the numerator 0, as long as it doesn't make the denominator 0. So if I'm setting this top to 0, solving it for x, so 3x equals -1 divided by 3. So the x-intercept is -1/3. So it's going to cross the x-axis at -1/3, 0. So that's the x-intercept. The next thing that we find is the y-intercept, which means replace your x's with zeros to find the y-intercept. So the y-intercept would be at 3 times 0 plus 1 over 0. So if this occurs, if you plug in a 0 for your x and it turns your denominator into zeros, this means there is no y-intercept because it made the denominator 0. Now it wants us to choose the correct graph. So if you're looking at these graphs, talking about what we have discussed, let's see, the x-intercept was at -1/3, 0. So it's crossing through the x at -1/3. Well, this one's crossing through, it looks at positive. That one's crossing through the x at negative. That one's crossing through the x either at 0 or positive, and this one's crossing through at 0. So it looks like it should be at A. Let's think, where is the y? Oh no, it's not A because it crosses through the y. Because remember, there is no y-intercept, so it cannot cross through the y-axis. Oh, it is A. That doesn't cross through the y. It comes right up to it, but doesn't cross it. Comes right up to it. So it is that A graph. I don't know what I was looking at there. All right, number 10. All right, same thing. We're going to find all kinds of information about this graph. The function on number 10 is x minus 7 over x plus 5. So again, the domain is the 0 of the denominator needs to be excluded. So let's see, what makes that denominator 0? If I set it equal to 0 and then subtract that 5, I'll have x equals -5. That needs to be the exclusion on the domain. So that would make it -infinity to -5 in union with -5 to infinity. The next part of that question wants to know any x or y intercepts. So the x-intercepts is the 0 of the numerator. So if I set my numerator this time equal to 0, solve it for x, so add the 7 to both sides. So x equals 7, so that's going to cross through the x-axis at 7, 0. Then we'll find the y-intercept, which means go to your function and replace these x's with zeros and see what you get. So I'll have 0 minus 7 over 0 plus 5. 0 minus 7 gives me negative 7. 0 plus 5 is 5. So the y-intercept is going to be at 0, negative 7/5. Then it wants me to find the vertical asymptote, which again, just like the domain, it has to do with the 0 of the denominator. So x plus 5 equals 0. Solve it for x. So x equals negative 5. So since that's not also a 0 of the numerator, that is a true vertical asymptote. And remember, you put in the full equation of the line. So all of x equals negative 5. The horizontal asymptote. Now remember, the horizontal asymptote came from that chart. If the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote would be at y equals 0. If the degrees are the same like this, remember your horizontal asymptote is going to be at y equals, again, since the degrees are the same, I look at the coefficient of these x's, which is 1 over 1. So just y equals 1. That would be the horizontal asymptote. And then it asks about the oblique asymptote, and remember, none of these graphs are going to have oblique asymptotes. So there is no oblique asymptote. Okay, so looking at these graphs, let's pick out which one. It should cross through the x-axis at 7, the y-axis at negative 7/5. Then look, this is a good way to exclude some things, because it's going to have that vertical asymptote at x equals negative 5. Well, look where this one's vertical asymptote is. It's at positive 5. This one looks like it's at negative 5, but this one's at positive 5, and that one's at negative 5. So it's either B or D. So let's look at the other things. That the horizontal asymptote is going to be that horizontal line, and where should it be going through? At y equals 1. So if I've narrowed it down to these two, because the vertical asymptote needs to be at negative 5, look, this one, the horizontal asymptote is at positive 1, and that one looks like it's below the x-axis, so that's at a negative situation, which I need it to be positive 1. So that narrows it down to the B choice. All right, number 11. Solve the following inequality. You have x minus 1, x plus 3 is less than 0. So what I'm going to do is set those two factors equal to 0. So here, if I add 1, x equals 1. Here, x plus 3. Subtract the 3. So x equals negative 3. I'm going to put these numbers on the number line and divide the number line into 3 intervals. Let's see, negative 3 would come before the 1 on the number line. So here's my 3 intervals. So remember, this is where we made that chart talking about the test points. And then we plugged each test point. We picked one out of each interval, and we plugged those in to each section here. So x minus 1 and x plus 3. And then we multiplied those signs. That's all we cared about, was the signs, to get what the sign of the answer would be. So a test point from this interval would be anything below that negative 3. So I'm just going to choose negative 4. A test point in between this negative 3 and 1. So I'm going to choose 0 since that's in between those numbers. And then this interval would be any number greater than 1. So I will just use 2. So remember, all we care about is the sign of what happens when we plug these test points into these intervals. So if I put a -4 in for this x, I'll have -4 minus 1, which is a negative. If I put it in here, -4 plus 3, that's also a negative. But if I multiply those two together, that would give me a positive answer. Now do the same thing with the 0. Put the 0 in here. 0 minus 1 is negative. Put the 0 here. 0 plus 3 is positive. If I multiply those signs together, it would give me a negative solution. And then the last one, if I put the 2 in here, 2 minus 1 is positive. 2 plus 3 is positive, and when you multiply two positives together, you get a positive. So then, this is what you're looking at, these signs. I come back up and I'm trying to find where this graph would be less than 0. Well, how do you be less than 0? You have to be a negative number. So I'm looking in the negatives. So where did that test point come from? It came from this 0, which was this interval on this number line. So everything in that interval is included. So where would I be talking about? Everything from -3 to 1. Number 12. Let's see, I've got x squared minus 2x minus 20 greater than or equal to x minus 2. So I'm doing the same kind of problem. I need to get this over to this side, and so I can set it equal to 0 first. So I need to subtract x and add 2 to both sides. Minus x plus 2. Greater than or equal to, this side becomes the 0. Over here I have x squared. Negative 2x and negative 1x gives me negative 3x. Negative 20 plus 2 is negative 18. Now remember, the other way that we did this was we looked on our calculator. We can put that in our calculator, this function that we have. Go to your y equals, put in the x squared minus 3x minus 18, and then graph it. Because remember, what are we trying to find? This wants to find where this graph is greater than or equal to 0, which this is the 0, that x-axis. So where is it greater than? Above the x-axis. Well, right here is above it. Then from here to here is below it, and then it goes above it again, which means it's above it from all the way to here, but not here. But then all the way from here to infinity. So from everywhere from negative infinity to that -3. Now, that -3, since it's greater than or equal to, we're going to put a bracket around it. Then we're going to skip this part because that's where it goes. Oops. That's where it goes below. And then we're picking up again here at 1, 2, 3, 4, 5, 6. So starting at 6. To infinity. So in union with 6 to infinity. And again, the 6 has a bracket since it's greater than or equal to. Number 13. X squared plus 7 less than 2x. So again, I'm going to set it equal to 0 first, so subtract the 2x. Now, this minus 2x is going to go in between these, right? It needs to go between the x squared and that constant. So I'm going to have x squared minus 2x plus 7 is less than 0. So once again, if I plug that into my y equals, x squared, there you go, x squared minus 2x plus 7, and graph it. So what am I looking at here? I'm looking at a graph that doesn't, if I'm talking about less than, I'm talking about below this x-axis. This is a parabola, which means if it starts here and just goes up both ways there, it's not ever going to cross and go below. So this is the one that was that null set. It just doesn't go below the x-axis. Number 14. This is the section where we moved into the composition of functions. So f of x equals 3x plus 4. G of x equals x squared minus 2x minus 6. And it wants me to find g of f of 7. Oops. Hang on. Forget that. G of f of 7. Which means this is the first thing that you find. Remember, you always find whatever is there first. So I'm finding f of 7, which means I will go up to my f function, find the x, and replace it with a 7 to see what I get. So I'll have 3 times 7 plus 4, or 21 plus 4, which is 25. So that takes care of the f of 7 part, but now I need to find g of whatever that solution was, which is 25. So I'll go to my g function now and replace the x's here with 25. So I'll have 25 squared minus 2 times 25 minus 6. And then do that math. 25 squared is 625 minus 2 times 25 is 50 minus 6. And then just punch that in your calculator. So 625 minus 50 minus 6 gives me 569. Number 15. F of x equals x plus 12. G of x equals x minus 12. It wants me to find f of g of x. So the g of x would mean go to my, there's g of x, just right there. It's just plain as day. G of x equals x minus 12, which is now telling me that I need to go to my f function and plug in this solution. So I'm plugging in this for x. So if I go to my f, I'm going to replace the x with x minus 12. So when I come up to f, the f function, the very first thing I see is that x. So I'm going to replace it with this x minus 12. Bring down that plus 12. The minus 12 plus 12s cancel, so you're just left with x. Now, I'm going to do the same thing, but the other way around. So g of f of x. So this time I'm finding f of x first, which is x plus 12. Which means now I'll go to my g function and replace the x with x plus 12. So I'll have, right off the bat, x plus 12, then the minus 12. So again, the plus 12 minus 12 cancels. So it's also x. And then it's going to ask you to find the domain of both of those. So the domain, remember, you look for any restrictions here, nothing, and the answer, nothing. So no restrictions on either of those. So the domain of both of them would be that negative infinity to positive infinity. Number 16. Finding the equation of an inverse relation. So if I have x to the third y equals negative 4, and I'm trying to find the inverse, if I'm just, all I need to do is flip-flop that x and y. So I get y to the third x equals negative 4, and it's multiple choice, so y to the third x equals -4 would be the B solution. All right, 17 and 18. These are the ones that y'all are going to like. Remember, if you're wanting to use the horizontal line test on these. So the horizontal line test is telling whether or not the function is one-to-one. If your horizontal line, if you draw a horizontal line and it only touches it once, then yes, it is one-to-one. So 17 would be yes. Then look at this one, if it touches it twice, like it does here and here, that means no, it is not one-to-one. So that's all that 17 and 18 are doing is the horizontal line test. So number 19, the function is 8 over x plus 4. So if you'll remember, you have to determine whether it's one-to-one or not. And if you're not sure, you can put that in your y equals and see if it passes the horizontal line test. So if I put in 8 over x plus 4, and graph it, you'll notice that it makes one of those rational functions that it does pass the horizontal line test. So it is one-to-one because a horizontal line won't touch it more than once, which means now I can find the inverse of this. So here, I changed this f of x, turned it into a y since they mean the same thing. Now interchange your x and y. So now you'll have x equals 8 over y plus 4. And then solve it for y. So this is the one, since the y was in the denominator, I'm going to put it up, I'm going to multiply both sides by that denominator so that I can cancel it. So it cancels it over here. So all you're left with is that 8. Here, if I distribute this x, I'll have xy plus 4x. So again, if I'm solving this for y, I need to now subtract the 4x. So now I have xy equals 8 minus 4x, solving for y, so I need to get rid of the x, so I'll divide by x. So y equals, you can, just leave it just like that, 8 minus 4x over x. So that would be the inverse function. All right, number 20. So f of x equals 5x squared plus 3, but it only wants me to use the part of the graph where x is greater than 0. So when I put this in to check if it's one-to-one, 5x squared plus 3, and graph it, it's going to make a parabola since it's that x squared shape, but it only wants me to use this part of the graph where the x's are positive. So this half of the graph, so not looking at that half. So that half, that's what makes it pass the horizontal line test, because I'm only looking at the right half of the graph. So I do need to find the inverse. So again, I will change the f of x to a y. Interchange x and y. So x equals 5y squared plus 3. And then solve it for y. So subtract the 3. So x minus 3 equals 5y squared. Still trying to get y by itself. So get rid of that 5 by dividing both sides by 5. So that cancels the 5. Now I'm just down to y squared over there. This side has an x minus 3 over 5. Now to get from y squared to cancel out the squared, I will square root. So the square root cancels out the squared. So there's my y. And then here is the inverse of the function, just the square root of x minus 3 over 5. 21. 21 is just that where we found this in the calculator, we're just finding e to the 6th power, which means you just go to your calculator. The E button is to hit the second, and then come down here to the LN, because right above it is the E, so you'll just type in E, and it already puts you right up there in the exponent like you want to be, so you just type to the 6th power and hit enter. So you have this big long decimal that we're going to carry out to 4 spots. So 1, 2, 3, 4. So it wants me to stop at this 7. So the 9 will tell me to round that 7 up to an 8. So I would just have 403.428 and then round that 7 up to an 8. All right, 22. All right, 22, again, it's picking out a graph. If you wanted to, you could go straight to your y equals, clear it out, type in 2, then raise it up because you want to go into the exponent. And then what is your exponent? Your exponent is just an x. So I type in x for the exponent and then graph it. And if you'll recall, the only one of these that even has the exponential shape is this C. That's linear, that's quadratic. This is the only one that goes in the direction that an exponential graph should. So it would be C. 23. Same thing. I can go to my y equals 1 over 6. Raise that up to the x power and graph that one and see what it looks like. Now, just like the other one, there's only going to be one that will match that. These are not, this right here, since the base is less than 1, that makes the exponential graph have that shape where it comes down like that. So it looks like it would be this B right here. Starts over here. It's not, see, this one has the right shape, but look, it doesn't go past that y axis like this one does. So B. Okay, number 24. So on this one, on the graph, what I'm going to be concerned with is these two things right here, that you know what the transformation is doing. So if you have f of x equals 4 to the x plus 3. So if you're looking at your choices, the first thing is you're going to pick out the base. This right here is your base, 4 to the x power. So this right here is what that would be. Now, this right here is an outside number. And what do outside numbers do to our graph? They move them up and down, and you go with the sign. So this plus 3 outside here will shift that graph up 3. I'm not even going to be concerned with graphing that. I just want to know that you know what the base is and what that transformation would be, that it would be moved up 3. All right, last one. This is the one where we did the compounding interest, number 25. The formula that you use is A equals P, open parentheses, 1 plus R over N, then raise it to the NT. What these letters stand for is the P is your principal, the R is your interest rate in decimal form. The N is the number of times that the interest is compounded. And then the T is the number of years. Okay? So the first part of this, I just need to come up with the formula that I'm going to use to figure out how much money I will have after 0, 3, 6, and 10 years for this part. So the first thing I need to do is just come up with the formula. So plug in what you know. Let's see. A equals, the principal is how much is invested. So in this case, $58,000. Open parentheses, 1 plus. The R is the interest rate. If you look at the problem, the interest is at 6.5%. Now, that's the same thing as saying 6.5%. But I still need to turn this percentage into a decimal, so I will move the decimal point 2 places to the left and fill that open spot with a 0. So 0.065 is my interest rate in decimal form. So 0.065 over N. The N is the number of times it's compounded. So if you look on your thing, it will show that it is compounded quarterly. Let me plug my computer in so it doesn't die right now. So if it's compounded quarterly, that means 4 times a year. So that'll be a 4. Now, the exponent is N, which again is 4, the number of times compounded, times T. That's the number of years, and that's what I don't know. That's what I'm going to change every time. Now, remember, you need to do this addition in your just plug it in your calculator. 1 plus 0.065 over 4 gives you 1 point. So 58,000 times 1.01625 to the 4t. So there is your formula. Now, if you'll remember, this was the one that we can actually put that formula in our y equals. So if I put my formula, 58,000, open parentheses, 1.01625, close it. Then I need to go up to the exponent, 4. So since my calculator doesn't have an t, I'm just going to use that as an x. Okay? Now, I want to look at the table because this will give me the answer to the rest of these problems, because then it wants to know after 0 years. So remember, the x represents the number of years because that was the t. So after 0 years, you still have 58,000, right? You just put your money in. It hadn't grown at all. So 58,000. After 3 years, so I go down here to where it's 3 and then look at it, and it shows me $70,378. After 6 years, so I just go down to the 6 and it shows me $85,397. And then the last one, 10 years. So that shows me $110,522. All right, I hope this works good for y'all.